Follow the Water, presented by Science at NASA. As Arthur C. Clarke once remarked, how inappropriate to call this planet Earth when it is quite clearly ocean. Indeed, Earth is a water world. The dry land most of us call home covers less than a third of the planet's surface. More than 70% of Earth is underwater. As the lifeblood of our planet, water moves with a circulation as complex as that of the human body. Evaporation, condensation, and precipitation transport warmth and moisture from ocean to ice pack, from river to rain cloud, from tributary to tundra, sustaining life and setting the stage for weather and climate. The water cycle, so familiar to all school-age young scientists, is one of the most dynamic and important elements in our studies of Earth, says John Grunsfeld, Associate Administrator for NASA's Science Mission Directorate in Washington, D.C. We're about to launch a new satellite that gives us critical information about how the water cycle works. It's called the Global Precipitation Measurement Core Observatory, or GPM for short. Built by NASA and JAXA, the Japan Aerospace Exploration Agency, the satellite is scheduled to launch on February 27th from the Tanegashima Space Center in Japan. GPM will fly 253 miles above Earth in an orbit inclined 65 degrees to the equator. This orbit allows the satellite to monitor precipitation all the way from the Arctic to the Antarctic circles. Working with a network of other satellites, some already in orbit and some planned for the future, GPM can measure rain and snow every 3 hours anywhere on the globe. The kind of data we'll get from the GPM network is unprecedented, says Gail Skowronek-Jackson, GPM project scientist at NASA's Goddard Space Flight Center. We'll be able to observe detailed characteristics of rain and snow systems that are extremely important for improving weather and climate forecasts. Normal operations will begin about 60 days after launch. Data will be downlinked through NASA's Tracking and Data Relay Satellite System to NASA's Precipitation Processing Center in Greenbelt, Maryland, where it will be processed and distributed over the Internet. GPM carries 2 instruments to measure rain and snowfall: the dual-frequency precipitation radar and the GPM microwave imager. Compared to instruments flown on previous Earth science satellites, GPM's precipitation radar and microwave imager can see deeper into clouds and detect smaller particles of rain, ice, and snow. The radar will be able to form 3D profiles of precipitation, revealing the inner workings of cloudy storm systems. The microwave imager will measure not only heavy and moderate rain, as other satellites do, but also light rain and snow, 2 forms of precipitation important over mountain ranges and high-latitude sites in North America, Europe, and Asia. What we learn from the GPM network, concludes Grunsfeld, will help us cope with future extreme weather events and manage freshwater resources in a changing world. Make that water world. For more news about NASA's missions to take the vital signs of our planet, please visit science.nasa.gov.